beamforming network based on active phased array. The project target is to design the beamforming system which could feed massive antenna elements for several hundreds, which combined with beamforming core chip with phase and gain control. And it is expected to have convenient antenna structures. There's some challenges and innovations about my project. The first is a massive MIMO multi-layer feeding network for like 16 inputs and 512 outputs. There's some information from the pictures about recent single-layer beamforming system, which could work around 30 GHz, and the bandwidth is less than 1 GHz. So the second challenge and innovations for my project is to have like 2 to 3 GHz bandwidth, which is wider. And the third is novel reconfigurable waveguide transitions with 2 modes at 20 and 30 GHz respectively for downlink and uplink, and also the reconfigurable antenna array structures. This is a beamforming network. It consists of the feeding network based on the power dividers, the code chip with the phase and gain control, the waveguide connections, the PA and LNA, the antenna array, the power supply, and the control sections. I cooperate with the TESLA company, so parts of the several parts in my project will use the TESLA products. There are some information about the commercial core chip for K and K band. And this is the roadmap of my project. The blue parts are the tasks which have been completed, including the basic principles, the power dividers with loads and without loads, the waveguide transitions, and the feeding networks. The green parts now I'm working on for the antenna array and the 2 input and 4 output system sample to show the operation performance. Now I'm almost complete the design and the simulation of all my project, and I'm preparing for the fabrications to get some merit results. This is the SSL structure power divider, which is very suitable for multi-layer network in PCB. It have a wide bandwidth which could work from 17 to 32 GHz, which includes both 20 and 30 for downlink and uplink. And I use the open stub circuit to help to match impedance at target working frequency point. And this structure is without load, so it have low isolations, but in application it still could work when we keep the same phase and amplitude of 2 outputs. There's some information about the SSL structure power divider with load. So it could save from the S parameters. When it have loads between the 2 output, it will increase the isolation a lot. And when it increase the isolation a lot, it will also increase the tolerance for the multi-layer fitting network a lot. This technology is embedded resistor PCB technology. We could see the side view from the pictures. It is a buried resistor in the dielectric layer, but due to its high cost, I think it's not very cost efficient for the commercial applications. There's some information about the MIMO fitting network. In my design, the 2-input and 4-output network, or 4-input and 16-output network could also be the unit element and could extend to over hundreds of outputs. So this is a 4-input and 16-output example to show the performance, to show the function. And each layer have one input. The signal from each layer will be divided to equal 16 parts and will be combined and connect to each element, antenna element at the bottom, at the top of the PCB. So every antenna element will include all information from all inputs. And the core chip will be installed on bottom of the PCBs. The waveguide transitions, the SSL to waveguide transitions are also designed for the beamforming applications based on the active phase array, active phase antenna array. And in modern satellite communications, the system needs dual band operation frequencies for separated uplink and downlink. So it normally to use the separate two system to reduce the influence and the interference between them. In this design, so it will share the same PCBs and only change the replace the metallic waveguide parts to work at 20 or 30 gigahertz modes. So the waveguide structure is very popular in transition technology for its low loss, wideband performance, and a simple structure. In this designs, it will reduce the cost on manufacture and is simple to install and replace for its reconfigurable structures. And also it's very suitable for the MIMO beamforming system. This is the structure of the waveguide transitions. I use the step transform to transform the propagation mode from the SSL to the waveguide. And we could see from the pictures, the metallic waveguide part could be overall installed on top of the PCB and fixed by screws. As I just mentioned, every element will have the combined signal from all inputs, so it have very high flexibilities for antenna elements and beams. For example, we could choose to use the like a 2x2 or 4x4 array for one beam and control the directions by the core chip with the phase and gain control. And it's a similar like a sub-array, but it's reconfigurable and could be controlled. And also the radiation directions and angle, which are also could be controlled by the control the phase and the gain in the core chips for the every antenna element. And for LEO application, it also should support circular polarization. The overall gain, the multi-beam function, and the illumination area will be affected, and there are some trade-offs between the antenna size and the element numbers. The horn waveguide antenna structure is very suitable for the beamforming technology for its easy installation and manufacture for the MIMO structure, and also it could increase the gain. The rich structure will help to minimize the waveguided antenna dimensions. There are some structures about the single waveguide antenna and example of a 2x2 antenna array. In this design, I also designed the reconfigurable waveguide linear polarized waveguide antenna part, and also the circular polarized waveguide antenna array part to have more flexible functions for different purposes in applications, which could only replace the waveguide part. And there are some simulation results about the circular polarized waveguide antenna and also the linear polarized waveguide antenna. So yeah, and thanks a lot for all the support and resource from the Tesla project for the Tesla company and the Harvard World University. So, any questions about?
Okay, thank you so much. If you have any questions, you can just ask or write and I can read it.